Right, continuing on with section 3-3, what I'm going to be covering is the properties of logarithms. So once again, this should be all review from Algebra 2. And using these properties, we're definitely going to be using one of them, our power property, but the others are going to be dependent on, how we choose to go about solving our exponential function. So it's definitely important to be able to understand these properties and be able to use them. So I'm going to talk about the properties of logarithms. I'm also then going to talk about the change in base formula. So first of all, when we start solving logarithms, you're working with exponents and you're solving for exponents. So to help us fully understand the properties of logarithms, let's just take a look at what our power properties do. When we multiply two powers together with the same base, we add the exponents together. So we get x to the power of m plus n. So just a reminder that if we were to take x to the third and multiply it by x to the fourth, we would add those powers together and we would get x to the seventh. If we were to do division, then we subtract our exponents. So this would be x to the power of m minus n, making sure that you would have the same base. So if we had something like x to the seventh divided by x to the second power, 7 minus 2, that would end up giving us x to the fifth. If you take a power of a power, well, that's when we do our multiplying. So x to the power of m times n. So if I take x squared and I want to take that to the fourth power, I would multiply this and we would get x to the eighth. Well, if you can recall this, that's also going to kind of work the same way when you're working with your properties of logarithms, because again, when you're working with logarithms, you're solving for the exponent. So the product rule, when you take the logarithm of a product, what we're going to do here is we're going to add the logarithms together. So thinking about that, when you take x squared and you multiply it by x to the fourth, we add the exponents together. So we take 2 plus 4. So here we're taking the log of x plus the log of y. Notice what I'm doing here too is that I'm keeping it the same base. So log base b of x times y equals log base b of x plus log base b of y. Next, when you look at the quotient rule, so if I take a logarithm of a quotient, so I'm dividing here, now I'm going to be working with subtracting those logarithms. So once again, if I take x to the fifth divided by x squared, I would subtract, taking 5 minus 2. So now I'm taking the logarithm of a quotient. I'm going to subtract the logarithms. I'm going to expand upon this, and you're going to take those exponents and subtract them. The last one is probably the most important one that we talk about here, and when you take the power rule. And the power rule here is when you're taking something to a power. Well, then we talk about multiplying. What the power rule does is it brings our power out in front, and it takes x times the log base b of that y. And the reason why this power rule is so important to us is because when we start solving for exponents, we want to make sure that we get that variable of x out of our denominator. And so by multiplying and taking the log base b of y to the power of x, that x is going to come down out in front. So a couple things just to kind of practice this, being able to expand logarithms as well as being able to compress them. So what I see here is I've got the log, and this would be a base 10 logarithm of the product of 8x and then y to the fourth. So I could go ahead and start with this. Since I'm multiplying, I could take the log of 8 plus the log of x plus the log of y to the fourth power. So here I'm expanding this logarithm. Since I'm taking the product, I'm going to add them all together. I can use one more property here because now I can use that power property, and I could bring the 4 out in front, and so I would get log of 8 plus the log of x plus 4 times the log of y. And so here I'm expanding this logarithm. Here's another one. So I've got a couple different things that are happening. This time I'm dealing with a natural log. All these properties hold true for natural logs as well. So when I look at this natural log here, I see that square root. What I'm going to go ahead and do here is I'm going to rewrite this using a power. So I'm going to take this as x squared plus 5 to the power of 1/2, and then divide this by x. So that square root here is the same thing as a power. So now I see that I've got the logarithm of a quotient, so that means I'm going to subtract. So I'm going to go ahead here and take the natural log of x squared plus 5 to the power of 1/2, and then I'm going to subtract the natural log of x. I can go one step further here because I've got a power, and I can use the power property, bring that out in front, and give this here to 1/2 times the natural log of x squared plus 5 minus the natural log of x. And that's how I'm going to leave it. Now, the biggest misconception that people make here is they think that you can go ahead and distribute that natural logarithm. We cannot do that. You're taking the logarithm of this sum right here. If it was multiplying, we could do that. But since it's adding here, you cannot distribute that natural logarithm. We've got to make sure that we keep that all separate. All right, what if we wanted to condense a logarithm? We wanted to put something together. So I see that I've got a working with natural logarithms here, and I'm just going to go ahead and try and reverse this idea of using some of my properties. One of them that I can do here is I could use that power property and bring that 2 up. So I have the natural log of x to the 5th minus the natural log. Actually, I need to put this in parentheses, so I'm going to take that whole thing there. So minus the quantity of the natural log of x plus the natural log of y, all to the power of 2. You also could bring up the -2 if you wanted to. So I could make this a plus right here and make that a negative. That's totally possible. So I'm just going to go ahead and keep it that way. Here, when I look in the inside here, I'm adding 2 natural logarithms, so I can put those together by using multiplication. So I have the natural log of x to the 5th plus, and then this is going to be the natural log of xy to the power of -2. And then lastly, what I can do is, since I'm adding these natural logarithms together, I can go ahead and do that working with the product property as well. So I can have the natural log of x to the 5th times the quantity of x, y to the power of -2. And I could go ahead and simplify even within here. Since this is going to give me x to the 5th, I've got, I got x to the 5th. I'm going to have x to the power of -2. I'm going to have y to the power of -2. X to the 5th and x to the power of -2. Put those together. That's going to give me x to the 3rd. So I can have natural log x to the 3rd times y to the power of -2. Another option that would be possible here is doing the natural log of x to the 3rd divided by y squared too. So that would be an alternate option for us. All right, so there's condensing, there's expanding. This whole idea now is going to help us when we start looking at trying to solve logarithms that we cannot do in our heads. Our calculators do log base 10 or log base e, but what are we going to do if we have something like this, log base 4 of 7? So we're going to be using a process called the change in base formula, but there's no need to memorize this formula, and I really suggest that you don't memorize it, because when we start looking at solving exponential functions, we're going to have to use this whole idea of using our power properties to do so. And so rather than memorizing a formula, let's just look at a process of how we can solve a logarithm here, like log base 4 of 7. So we're going to set that over here equal to x. Well, since my calculator is not going to do this one here, I'm going to go ahead and put it into exponential form. So I'm taking 4 to some power equals 7. So we talked about doing that last week. Well, if I think about it, I have no idea what 4 to some power is going to equal 7. So what I'm going to do here is I am going to take the logarithm of base 10 of both sides. And I'm going to take log base 10 because that's what my calculator calculates. I also could do log base e if I wanted to do that. So I could go ahead and do the natural log as well. I'm just going to get my calculator up and moving here. Now, by taking the logarithm of both sides, what that allows me to do is use my power property. Get that out of the way for now. And that's going to allow me to bring this x out in front. So now I have x times the log of 4 equals the log of 7. Solving for x, I can divide both sides now by log of 4. Again, these are all base 10. And so going to our calculator, which I have up right here, I'm going to go ahead and just take the log of 7, make sure you close your parentheses, divide it by the log of 4, and we get 1.40. So x is about 1.40. You also can do this with natural logarithms. So again, if we're looking at 4 to what power is equal to 7, I can take the natural log of both sides, so just working with a base of e. The power is still going to come down out in front, so x times the natural log of 4 is equal to the natural log of 7. Solving for the value of x, I'm going to divide by the natural log of 4. And so then you would just go to your calculator, the natural log of 7 divided by the natural log of 4. And you'll notice that we'll get the exact same answer. So x is approximately 1.40. Just to kind of show this once again, so log base 6 of 24, again, I'm trying to figure out what this is equal to. 6 to what power equals 24? Well, I know 6 times 4 equals 24, but I'm working with exponents here. So I'm going to take the log base 10 of both sides. That brings this x out in front. So now x times the log of 6 equals the log of 24. Divide both sides by the log of 6. And then I'm going to get x is about, once again to the calculator here, take the log of 24 divided by the log of 6. And I get 1.77. Absolutely, you can go ahead, and you can use natural logs to work with this too. Either one would work for this. I'm going to go ahead and just work with a natural log. So let's say we wanted to evaluate the natural. Well, I suppose never mind, because you could just do that on your calculator. So I was just thinking if you have something that is working with, say you have e to what power equals 17, or let's go 17, sure. So in this case here, you could take log base 10 of both sides, or we're going to be talking about how we can take the natural log of both sides, bringing down this exponent then. So x times the natural log of e is equal to the natural log of 17. Natural log of e is 1, so x equals the natural log of 17, which, if you realize here too, if I were to take this from exponential form and put it into log form, log base e of 17 equals x, we get the same thing here. Log base e of 17 is the natural log of 17. So again, it's not necessarily memorizing a formula, it's more so understanding that we can take a logarithm of both sides, and that uses that power property to bring it down. Here is the change in base formula, so you can use this. It allows you to just take any logarithm of any base and to convert it into any base, which most likely we like to work with 10. So it's just saying that if you had log base 7 of x, not of x, sorry, let's just go of 13. So then we could go ahead here and rewrite this as log base 10 of 13 divided by log base 10 of 7. And ultimately we're getting the same thing just by solving the exponential equation of 7 to the power of x equals 13. So here's, that was section 3.3. If you have questions, make sure you jot them down. Otherwise, just you're going to be working on your assignment for the remainder of class, and work together with each other, try and help each other out. There might be a couple challenging problems that are on there, and I want you to try and do the best that you can to work through those.